Hello everybody, getting ready to do lesson 10.6 of Pre-algebra Math Part 1. If you want Part 2, email me here. And today's lesson is 10.6, surface areas of pyramids and cones. We have a 38-point classwork sheet today, and then we have 25 points here of note-taking. Here's our standard, and then surface area problems. Today's bellwork teachers, multiple choice, what is the approximate surface area of the cylinder here, students? Then draw a net. Then find the surface area here, round to the nearest whole number. This is somewhat extensive. I give your students 8 minutes to do this bellwork. Okay, welcome back. For the solutions of today's bellwork, here is our surface area solution here for our cylinder here, 80 square yards, 2 pi r squared plus 2 pi r h. So we have our lateral area here, which is 2 pi r squared. See, 2 pi r squared will be our top and our bottom, and then our lateral area will be here. So when we get through with our math there, we come up 25.6 pi, which is 80.4. And then our 80.4D would be right about here. And then for number 2, here is the net for that. Isn't that a pretty cool net here with the triangular sides there? And then here is the flattened out surfaces area of it. And then here is the math here that expresses the two-dimensional areas of this net. And when you add it all together, it comes to 1,056 square feet for the net of that. Okay, page 1 of our classwork today, surface areas of pyramids and cones. You found surface areas of prisms and cylinders. You'll find the surface areas of pyramids and cones, so you can recall that the base of a pyramid is a polygon, and the lateral faces of the pyramid are triangles with a common vertex. The height of a pyramid is the perpendicular distance between the base and this common vertex. In this lesson, all pyramids are good to know. In a regular pyramid, the base is and this would be a regular pyramid here. We have what looks like a square base. This is your height here from your base, perpendicular from your base up to the vertex, where the slant sides all meet in the vertex here. The base is a regular polygon, and all the lateral faces of the pyramid are congruent isosceles triangles. So the sides are all isosceles here. They have 2 equal sides and a base here. The slant height of the pyramid is the height of any of these triangle lateral faces. So the slant height here would be the actual height of the triangle itself. The slant height. So what does that mean for us? Well, find the slant height of the pyramid. This is the model of the pyramid at the California State University, Long Beach, which has a height of 192 feet. So this would be the direct height here from the base. The base of the pyramid is a square with a side length of 345. So each of the sides here of the pyramid is 345 feet. What is the slant height? So we want to find the L here is what we want to find. The slant height L of the pyramid is the hypotenuse of a right triangle. So it would be the hypotenuse here of this right triangle here would be the slant height, which is right here. And then this is the slant height here. These are all hypotenuses of a right triangle. The length of one leg of this triangle is 192 feet. So 192 feet, so we have this here. This is your height. Here is your hypotenuse of this triangle here, which is the right triangle that determines the height of the pyramid itself. So L here is your hypotenuse. These are, that's another slant height, I would say. So the length of the outer leg is 345 over 2, which is 172.5. So this is 172.5. Use the Pythagorean theorem to solve this. So to find the L here, L squared, we add up our other two sides. We come up with this number here. We take square root of that, which equals our L, and we come up with 258.1, which is our slant height of the pyramid, is about 258 feet using the Pythagorean theorem. Now, find the slant height of the pyramid or cone. Here is our height. Here's a leg. And then our slant height would be this hypotenuse down here. We know this, so we should be able to find it. It's a right angle here. Find the unknown side lengths of the triangle, give exact answers. So we need to find this and this, students, for you. So let's do our guided practice first. So up here, we just add these together to find our hypotenuse here, which is this, the slant height there. And we get 52. When we do our math up here, the slant height of the pyramid would be about 52 centimeters here for that one. And then for you students, that's up to you. Okay, so page 7 now of our lesson. Here's our pyramid again. Our P is our lateral area. Our base is here. Then our slant height is here, call her L. Surface area of a regular polygon, of a regular pyramid. The surface area S of a regular pyramid is the sum of the base B and 1/2 of the product of the base perimeter P and the slant height L. So as a formula, here it is. Surface area equals base plus 1/2 PL is what it amounts to. This is a cool little formula for the surface area of a pyramid. Okay, students, in your own words, define height of a pyramid and define regular pyramid. In your own words, notebook page 8 on this lesson. Make that entry and I'll check it on Friday usually. And then slant height of a pyramid, define in your own words. And then the height of a cone, which we haven't covered yet, but we'll get there, so hang on to that. And then slant height of a cone, which we haven't covered yet, hang on to it, we will get. Okay, so find the surface area of a regular pyramid. Let's do this again. Find the surface area of a regular pyramid. Here we are. Our slant height here. We have a base here, a square base. Find the perimeter and area of the base. So perimeter equals 4 times 10 is 40. So there's our P. And then our base is 10 squared is 100 square centimeters. These are important dimensions. Find the surface area. Here's our formula, base plus 1/2 PL. So what's our P? We know our P. 100 plus 1/2, 40 times 13. There it is. Boom. Then we just do our mathematics there and we get 360 for the surface area of this pyramid. So there it is. 360 square centimeters for this pyramid. And let's go into another guided practice. Find the surface area of this perimeter here. Find the surface area of this pyramid. Find the surface area of this pyramid, students, for your independent practice. We have a base here. Well, they're giving you the area of this base, aren't they? So what do we do up here for this? Well, here it is. P equals 9 So here's our P here. 3 times 3 is 9. Our surface area would be P base plus 1/2 PL. So we have 3.9. Our base is here. And so we have 3.9 plus 1/2, 9 times 4 is 21.9. So here's the surface area of this perimeter right here. Find the surface area of this pyramid down here, students. That's yours. And that is lesson 10.6, part 1. Part 2 is available here, as well as all of your other course sheets. Thank you.